Section 3.2, number 42. Here we are given this quadratic in t, or polynomial in t. G of t is equal to t to the fifth minus 6t cubed plus 9t. We're asked to find the zeros algebraically. Use a graphing utility to graph the function and use the graph to approximate any zeros and compare them those what we get from the algebraic part. So this is a fifth order polynomial, but there is a t in every term. So I can pull a t out of each one. If I pull a t out of the 9, I'm left with a 9 there. If I pull it out of the 6t cubed, I'm left with 6t squared, and if I pull it out of the t to the fifth, I'm left with t to the fourth. So I can write this as t times t to the fourth minus 6t squared plus 9. Now, this is still, the stuff in the brackets is still a fourth order polynomial, but it is of quadratic type. So if I want to, I can write this as t times t squared minus 6 times my t squared plus 9. Alright, so this means is that I can now write this, I can now factor this thing out with t squared replacing what would be a normal x in the factoring. So I'm going to get g of t is equal to t times. The factors here, we have a 9 is a 3 and a 3, and a 6 is a 3 plus 3. But there's a negative here, which means that at least one of them must be negative. This positive here means that they're both of the same sign. So I'm going to get t squared minus 3 and t squared minus 3. So I'm actually going to get t squared minus 3 squared. So now if I'm going to look for the zeros of this thing, well, I can have t be equal to 0. So that's one of them. Or t squared minus 3 is equal to 0. Well, if I add 3 to both sides, this is true if and only if t squared is equal to 3. And so if I take the square root, I'm going to get both the positive and negative here, right? So t is going to be equal to positive square root of 3, which is about 1.7-ish. You plug it into the calculator, you can get all the decimals you want, but it's about 1.7-ish. And we're going to get t is equal to our negative square root of 3, and that's about negative 1.7-ish. So let's look at the graph of this thing, and we'll see if we get our zeros at 0, positive 3, and negative 3. Oops. So if we look at the graph of our function, I've graphed it in terms of x instead of t because that's how our grapher works. And we see that we certainly have a 0 at x equals 0. So that means we had a 0 at t equals 0. We're going to have one at around negative 1.7-ish. It looks like it's actually a little less. 5, 6, negative 1.6-ish. Right, and we have this nice symmetric 1.7-ish on the other side. Okay? All right. So give that a look and try out the examples that I've asked you to do, and good luck.